So let's begin. So first of all, guys, you start with stating HO and HA. It's the distribution. HO is a distribution of the days of the week people order food for delivery is as claimed. Is as claimed. You can write them down if you want to write the 7%, but you don't have to. HA, as I told you last time, distribution. Can someone tell me what is that? Distribution of the days of the weeks. Okay, what would you put there? Is, okay, let me see what student says here. Not as claimed, or has changed. Not as claimed is good also. And you guys agree with me that the claim is in HA because it says they claim that the distribution of the days of the week that people are most likely to order food for delivery is different from above. So it has changed. Okay, so that's HO and HA. The next step, guys, is to find the test statistic, which we have this formula. And this is where we're gonna work together on this one. So I'm gonna start creating the table. I'm gonna put the categories right here. You can see Monday. Did he start with Monday? I think so. Tuesday, Wednesday, Thursday, Friday, Saturday, and then Sunday. Okay, I do that here. And then I'm gonna put the O's here. And then we'll do the E's together after I show you the screen. So for the O's, guys, just record what you see right here. So I'm gonna give you a chance to write them down, and I'll write them down at the same time. We have, for Monday, we have 43, and then 16, then 25, then 49, then 46, then one. Oh no, Monday is not 43, Monday is 16. So I made a mistake, I started with Monday, but it doesn't matter. 16, 25, I'm fixing this right now. And then 49, then 46, then Friday is 168, Saturday is 153, and then Sunday is 43. Here you go, guys. Watch. That's what we have. Now E's. This is where most of the work, guys, is done on the E's. The E's are the expected value. The expected values are if the distribution was working, what should we get? We have some percents, guys, so we're just gonna use the percent of the total. And since I started with Monday, I have to begin with Monday. Can you guys read what Monday is? I think it says 4%, if I'm not mistaken. Yeah, 4%. And we have 500 total. You don't have to add them up. So this is how you figure it out. It is a 40%, which is 0.04 times 500. And let me show you what Tuesday is. Tuesday is 6. I'll write them down first of all for you. Then Wednesday is 13%. Then Thursday is 10%. Then Friday is 36%. Saturday is 24%. And Sunday is 7%. So, and alpha here is 1%. And actually, guys, I don't need the book anymore. There you go. Let's do this together. I'm getting my calculator ready. So 4% of 500, guys, is 20. 6% of 500 is 30. 13% of 500 is what? 65. 10%, oops, 0.10 here, times 500 is 50. 36% times 500. If you multiply 0.36 times 500, you get 180, which is close to 168. So probably the distribution did not change. 24% of 100 is 120. Oh, there is a difference here. You see, we had 153, but actually the expected value is 120. And 7% times 500 is 35. Now, guys, the next step is to do O minus E. Just do the subtraction. 16 minus 20. I'll just write the first one. Negative 4. Then the next one, 25 minus 30, negative 5. 49 minus 65, negative 16. 46 minus 50, negative 4. 168 minus 180, negative 12. 153 minus 120 is 33. Oh, wow, that's big. This is, and 43 minus 35, guys, is 7 or 8. Again, if you add them up, you should get a 0 here. If you add all the E's up, you should get 500. If you add all the O's up, you should get 500. Now the next step, guys, is O minus E squared. So let's square your number and get answers. So we get 4 squared is 16. 5 squared is 25. 16 squared is 256. 4 squared is 16. No negative values anymore. No negative numbers. 12 squared is 144. 33 squared is 1089. And 8 squared is 64. And one more. If I wanted to do that question in this format, I will provide you with the table. You just fill it in with the blanks. Fill in the blanks there. Now, O minus E squared over E, guys. This is the O minus E squared. So you take this value, the 16, and then divide it by the E, which is 20. And don't do the division. Just leave them like that. The next one, 25 divided by 30. Next one, 256 divided by 65. Next one, 16 divided by 50. 144 divided by 180. That's a big number here. 1089 divided by 120. And 64 divided by 35. Yeah, I got the percents from the chart, the pie graph. It has the percents for each day. That's where I got them. I didn't make them up. The 4%, 6%, they're all given in the chart. They will be given to you always. And now the test statistic, guys, is this. Which is, just add up the last column. 16 over 20 plus 25 over 30 plus 256 over 65 plus 16 over 50 plus 144 over 180 plus 1089 over 120 plus 64 over 35. Okay, I'm gonna give you a minute to add them up for me. This is what I got. I got 17.595. Do you guys agree with this answer? Okay, great. Next step, we're gonna do the critical value and then we'll do the p-value. You do this, guys. That's step number 3. You sketch a graph like that. I'll show it to you in a second. And you put the critical value right here, chi-square 0. It's always a right tail test. This test is always a right tail test. No confusion here. It turns out to be a right tail test because chi-square is always positive. And in order to find this one, guys, we're gonna need table 6 with 2 things. Alpha, which is 0.01 here, and the degrees of freedom. And the degrees of freedom, for goodness of fit, guys, it's number of categories minus 1. So can someone tell me what the number of categories here? Days of the week. It's 7 days, minus 1 is 6. Okay, and let me show you how to do this using the table. Okay, guys, we need 1%, which is right here, and we need degrees of freedom to be 6 right here. So it's the gray shaded line. And where are we? I got 16.812. That's my critical value, 16.812. Okay, let's continue from there. Okay, now what is my test statistic, guys? My test statistic is 17.595. Here's how you make the decision. If the test statistic is bigger than the critical value, it's going to be on the right. So it's going to be right here. This is the test statistic. Where do I put it? Okay, that's chi-squared, which is 17.595. If the test statistic, guys, is larger than the critical value, you reject the null hypothesis. So reject HO. And if you reject HO, guys, and the claim in an HA, you support the claim. So you say there is enough evidence at the 1% level of significance to conclude or to support the claim, if you want, that the distribution of the number of days people order food for delivery, I'm just copying and pasting the claim, guys, has changed or is different from than expected. People order food for delivery has changed. So we believe it has changed. It's not the same. There is enough evidence at the 1% level of significance to conclude that the distribution of the number of days people order food for delivery has changed or is different from the expected one or the claimed distribution. Just cut and paste the claim. This is how you do this by hand. How do you do it using the calculator? So let's walk through it. you have to input the following, guys. L1 is the observed values, and L2 are the expected values. All right. These are the values. You put them in L1 and L2, and watch, guys. You go to stat, you go to tests, and you scroll up. And guys, you should not be lost here. You see the part D, which says chi-square GOF. GOF, as I told you, stands for goodness of fit test. So you just go to D, enter L1, L2. I'll tell you the mistake that students make here. They forget to change the degrees of freedom. Degrees of freedom is number of categories minus 1. I have 7 days, minus 1 is 6. And then hit calculate. And the P is 17.595, exactly what we got. And the P value is 0.0073. I'm gonna write it down. Don't worry about the last one here, just not relevant to us here. So if using P value, go to chi-square goodness of fit test, and the P value is 0.0073, which is less than alpha, guys. And then you reject what? HO. This is how we do it both ways. Okay, now we're gonna do an exercise where he asks us to check if a distribution is uniform or not uniform. So you'll have a very good idea about how to work with that. Number 15, page 535 in your textbook. An organization claims that the number of prospective home buyers who want their next home to be larger, smaller, or the same size as their current house is not uniformly distributed. To test this claim, you randomly select 800 prospective home buyers and ask them what size they want their next home to be. And the results are given, guys, right here. Out of the 800, 285, they said if they buy a house, a new house, they want to be larger. 224, they want it to be the same size. And 291 say they wanted a smaller house. So the table at the left shows the result. At alpha equals 5%, test the claim. The claim is the distribution is not uniformly distributed. Okay? So let me show you how to state the null and the alternative hypotheses in this one. All right, so let's grab a piece of paper. You need the entire sheet of paper for this. There you go. So it's number, we said 15 on page 535. Okay. HO. HA. You put distribution is uniform. And here, can you guess what is it gonna be? Distribution is what? It's a total opposite statement, guys. Not uniform. And he claims that the distribution is not uniform. So the uniform should go in HO. Whatever they claim that they begin with should always be in HO, and this is where your claim is. And now we do this. we have 3 categories only, guys, so it's not difficult here. Larger, same size, smaller, and I'm gonna write the O's for you, already given to us in the table. 285, 224, and 291. And we have a total of 800 homeowners. And what is alpha here? Alpha is 5%. Okay, I no longer need the book for now, guys. Okay, that should be a very short question, not much data to process. Now we need the ease. This is why I'm doing this question. He didn't give you any percents here, but he says uniform. The word uniform, guys, means every category gets the same thing. So everyone gets the same percentage. I have a total of 800. And how many categories do I have here? I have larger, same size, smaller, 3. All you have to do, guys, is just take the total and divide it by the number of categories for everybody. So everybody will get the same. This is what a uniform distribution is. What is 800 divided by 3? If you divide 800 divided by 3, you get 266.67. Let's round it just for convenience. So let's make it 267. So that will be 267, and that will be 267. So it's very easy to work with the word uniform. You just take the total that you have and divide it by the number of categories. For example, in the previous exercise, if he didn't give us the pie graph, and he asked, check if the distribution of days of delivery is uniform, you just take, those 500 and divide it by 7. Why 7? Because I have 7 days in a week. That's how you work with this. Okay, next, O minus E. So 285 minus 267 will be 18. 224 minus 267 will be negative 43. And 291 minus 267 will be 24. Now we do O minus E squared. Will be 18 squared, guys, negative 43 squared, and 24 squared. Let's do this together and tell me what the answers. Okay, so these are the O minus E squared. Now the last one, guys, O minus E squared over E. Will be 324 divided by 267. And this one will be 1849 divided by 267. That's a nice thing. Everything is divided by the same number, 267. And now your chi-square is this. Just add up the last row. Plus 1849 divided by 267 plus 576 divided by 267. And let me add them up and see what we come up with. $18.49 divided by 267 plus finally 576 divided by 267. My answer is 10.296. And now, guys, you do this. You skew the curve to the right, just like I did in the previous one. You put chi-square 0 here, you shade this area. And we need 2 things here. Degrees of freedom, which is number of categories minus 1, which is 2. I have 3 minus 1. and alpha is 0.05. And I'm going to show you the table, guys, in a second. Okay, let me show you the table. 0.05 is here, and 2, you can see it, guys, it's 5.991. Okay? So 5.991. Well, my test statistic, guys, is way too big. It's right here. So decision again is to reject HO. And if we reject HO, we conclude that the distribution is not uniform. There is enough evidence at the 5% level of significance to conclude that the distribution is not uniform. Okay, so that concludes section 10.1. If I am to do this using the calculator, guys, let's do that using the calculator. Using the calculator, see how easy it is, guys, using the calculator. You go to stat, edit, L1 first. Let me just clear it. You put 285, you put 224, and you put 291. Then you go to L2, clear it, and it's 800 over 3. I'm gonna put 800 over 3. I'm not gonna round it just like what we did, because calculator can do everything for us. And now go to stat, tests, scroll up, goodness of fit test, L1, L2, degrees of freedom. Don't forget to change it. It's a 3 minus 1, it's 2. And hit calculate. There you go. The test statistic is 10.3075, and the p-value, so using chi-square GOF test, chi-square equals 10.308, and the p-value is 0.0058. All right, guys, which is less than alpha. So we reject HO. Can someone tell me why the test statistic that we did by hand is different from the one that we got on the calculator? But I think the system will accept both if it was asking you to do what? Anyone knows why we got different answers? We got different answers because I rounded here. I put 267, 267, 267, whereas the calculator did not round. That's the only reason. So both answers are fine. So this concludes section 10.1, guys, and we're gonna head to 10.2. We're gonna do 10.1, 10.2, and 10.4. We'll be skipping 10.3. So again, we will be doing independence test. It's called chi-square independence test. It's to check whether two variables are related or not related. And I'm gonna show you an example here. One variable is the class level. Another variable is the political party. And you can test whether the class level of a person and the political party that the person would select are dependent or independent. And this is what we call a contingency table. That's what we learned in chapter 3, guys. to explain the contingency table. For example, guys, if you ask me what the number 4 means here, the number 4 means that there are 4 sophomores who support Democratic Party. If you ask me what 15 means, 15 means it's the total number of sophomores. 12 is the total number of juniors. What does 4 here means? It means there are 4 juniors who support Republicans. What does 3 mean here? 3 means there are 3 juniors who support neither Democrat or Republicans. What about the 40 here? You remember the 40 is the grand total. That's what we call the grand total. 13. 13 means the total number of people who support the Democratic Party. There are 13 this way. So this is what we call contingency table, and that's the table that we were going to be using. And the book also call it two-way table because it involves 2 variables. This is the class level, and this is the political party. What does association mean? Association means when knowing that one value of one variable imparts information about the value of the other variable. Where the 2 variables are categorical or quantitative with only finitely many possible values. So this is an example of it, guys. I explained the table to you, and you should understand how to use the table and how to interpret the table before we proceed. Any questions about the table? It is something that you've seen, if you remember, in chapter 3, working with tables like that. The test statistic, guys, for the independence test is the same. Chi-square equals sum O minus E squared over E. We're going to be doing the same thing. But the degrees of freedom is going to change here. It's going to be the rows minus 1 times the columns minus 1. For example, for this particular example, what would be the degrees of freedom? How many rows do I have here? I have 1, 2, 3, 4. Why didn't I say 5, guys, here? Can you tell me why it's not 5 rows of data here? You don't count the heading. The heading doesn't count here. When we talk about rows and columns of data, rows of data, I have 1, 2, 3, 4 rows. And how many columns of data, guys? 1, 2, 3, 4. We don't count that. Oh, sorry, I counted the total here, so I was wrong. It should be 1, 2, 3. We don't count the total because it's something we create ourselves. So we have 3 rows and how many columns? 1, 2, 3, 4. We don't count the total because we made the total. We can make the total ourselves. So if you want to figure out the degrees of freedom for this example, it will be 3 minus 1 and then 4 minus 1. What is 3 minus 1 here, guys? 2. What is 4 minus 1, which is 3? So the degrees of freedom is 6. So it's not number of categories minus 1 anymore because there are no categories here. There are 2 variables, one sitting horizontally and another one sitting vertically. So we do rows minus 1 and columns minus 1. So in order to use this one, guys, you already have the observed values. These are called the observed values that are given to you. What's given to you, usually called observed. I need to show you how to find the expected values, the expected frequencies. Once we do that, we'll just go back and do the exact same work as we did in the previous sections. The assumption in order to do the independence test, the expected values must be 1 or greater, and 20% of them should be, no more than 20% of them should be less than 5. So we should expect the expected values to be more than 5. How do you state the null and the alternative hypothesis? Watch, guys. These are the 2 statements that you always write. Just like in the previous one. Distribution is as claimed, distribution is not as claimed. Same thing here. Here you say the 2 variables are independent, or the 2 variables are dependent. So variables are independent, and here variables are dependent. Always, in any problem, you just state those statements. Now, instead of the word variables, guys, for example, if you go to the previous example that I showed you, you don't write variables, you write class level and political party are independent. Class level and political party are independent. Then we find the expected values, which I'm gonna show you how to work this out in a second. Then you identify the significance level. You find the critical value using table 6 or using the calculator, just like we did before. You find the test statistic using this formula, which you already are familiar with. You reject HO if the test statistic is bigger than the critical value. You fail to reject it if it is less. And then you state your conclusion in words. And then there is another way to do it using the p-value approach, which I will show you how to do that using the calculator in a second. So I selected an exercise. I'm going to show you how to do the work using the critical value approach with this example. So we have this example right here, guys. And we're going to do this one together. Let me show you how to work this one out. Okay. A sports statistician is interested in determining if there is a relationship between the number of home team and visiting team losses and different sports. A random sample of 526 games. So someone was asking me about the total. It's 526 here. Is selected and the results are given below. It says use the p-value. I'm going to use both methods to test the claim that the number of home team and visiting team losses is independent of the sports. So here's how you begin, guys. You begin HO and HA. I'll write them down here. You write number of home team and visiting team losses and sports are independent So whether you are a visiting here team or a home team and the type of sport are independent of each other, you know what HA is going to be, number of home team and visiting team losses and the sport are dependent or related, if you want to write the word related. What does he ask us to do here? If there is a relationship, so that means the claim is right here. Any questions about the first part, guys? So HO variables are independent, HA variables are related or dependent. You ask me why I put the claim in HA, because it says if there is a relationship, means they are related. Now for the O's. The O's are those numbers, guys, all those numbers. There's quite a bit of them. So there are no categories here, so you list them. And actually, I didn't allow enough room, so this is what I'm going to do. I'm going to put 39 here. I'm going to put 156. I'm going to put 25. I'm going to put 83. Then I'm going to put 31, 98, 19, and 75. I got the O's. And let me show you how to find the E's. There's quite a bit of work, guys, in finding the E's. So please be patient with me as I do this. Before I do it, I would like you guys to help me out compute the totals everywhere, this way and that way. So I'll give you a minute to work out the totals with me. Okay, here's how you find the expected frequencies. In any hypothesis test, guys, we assume that the null hypothesis is true until proven otherwise. Remember, the defendant is not guilty until proven otherwise. So we assume that the variables are independent. I don't know, guys, if you remember from chapter 3. If you don't, that's okay. Let me just state the facts, and then all you need to worry about is the conclusion that I'm going to give you at the very end. If two variables, if two events, A and B, are independent, we can write the probability of A and B equals probability of A times probability of B. If two events are independent, probability of A and B equal probability of A times probability of B. So if we assume that the variables are independent here, guys, and if you want to find, the probability that a team plays football and it is from a home team, it's a home team loss, we do football as A, home team loss as B, and we should get probability of A times probability of B. If I ask you guys, what is the probability of a team playing football? The probability of a team playing football is, the total that I have is 526. And how many teams do play football? I have a 70. So it's 70 divided by 526 times. We're doing this. Football and home team loss. What's the probability of selecting the team that it is a home, it's a home team loss, that has a home team loss? Well, the total, guys, is 526. And the probability is how many of those we have here? 303. So if the events were independent, this is the probability of selecting a team that plays football and that is from that is a home team losing that game. So that is the probability of football and home team losses. Now, if you want to find the expected frequency, guys, here's how we find the expected frequency. If I tell you guys I have the probability that a student will get an A in my class is 35%. If I have 200 students in my class, how many students do you expect to get an A? Can someone answer this question? How to do it? So the expected value always, guys, it is the probability times the number, the total, which is, call it MP. So the expected value in our case, watch, it will be, this is the probability times the total, which is, I have 526 of them. So look what happens, guys, here. The 526 and a 526 cancels out, so I'm left with this. I know it's a lot of work to get it, but you will see the end result is very straightforward. So the expected value that I got from the 39 that I worked out turns out to be 70 times 303 divided by 526. But now watch the summary, guys. You don't need to worry about this anymore. Here's how you find the expected values. Please pay attention. You have 8 observed values. You need 8 expected values. Here's how you find the first one. To find the expected value of 39, now listen carefully. You figure out the total of the row where 39 is, which is what? 303. You figure out the total of the column that 39 belongs to, which is 70. You multiply these two numbers and divide by the grand total. So it's a 303 times 70 divided by 526. I'll write it down. Now, guys, can you tell me how do I do 156? Watch, I'm gonna do the same thing. Watch me doing the work. What is the total of the row that 156 belongs to? It's a 303 times. What's the total of the column that 156 belongs to? It's 254. And then divide by the grand total. I didn't leave a room to find the answers, but that's all right. We'll put them somewhere else. 25, guys. Can someone tell us what would be the expected value for 25? I'll wait. Let's see what. All right, now we need to square 44. So 44 squared is 1,936. 10 squared, that's 100.
You put 256, so some of your answers are a little off.
Oh, did I put 256?
Few of them, yeah.
Which one?
I just deleted them off my calculator, but there was a few of them.
No, let me double check. No problem. Let's okay. So we got the O minus E's. We got the O minus E squared now. O minus E squared over E will be 1 over 40. This one will be 100 over, I'm getting the E's, guys, from here. 146. 0, you don't need to divide it by anything. 64, the fourth one, 91. 1 over the fifth one, 30. 100 over number 6, 108. 0, 0 over whatever. And last one, 64 divided by 67. Okay, guys, let's add them up, and that's your test statistic. It will be 1 over 40 plus 100 over 146 plus 0 plus 64 over 91 plus 1 over 30 plus 100 over 168 plus 64 over 67. Okay, guys, can you help me compute this, please? And let's get this done. See, guys, it's not any different anymore. You do this because it is a chi-square test. It's always a right-tailed. You put chi-square 0 here, and you need degrees of freedom, and you need alpha. And alpha here is, what did I say? Alpha, I didn't say. So let's use 0.05. I'm going to use 0.05. Okay, degrees of freedom, guys, is number of rows minus 1 times number of columns minus 1. So can you tell me how many rows and how many columns? I have 2 rows. So it's 2 minus 1. And how many columns do we have? Let's see. Times. I got football, basketball, soccer, and baseball, 4 minus 1. So your answer will be 2 minus 1 is 1 times 3, which is 3. So we need to go to table 6, look for degrees of freedom of 3 and alpha equals 0.05. So again, to use the table, alpha is 0.05, degrees of freedom is 3. It is 7.815. You can see it, guys. I'll write it down. And what is my test statistic? 2.997. It's somewhere here, guys, as you can see. This is 0 right here. So can someone tell us what's the decision? Is it reject or fail to reject HO? Fail to reject HO. And you conclude, you say there is not enough evidence at the 5% level of significance to conclude or to support the claim if you want, but they use the word conclude here, that there is a relationship between the number. I'm just copying and pasting the claim, guys. the number of home team and visiting team losses and the type of sport and the different sports they played. That is how to do the independence test. It was a lot, guys, because you have 8 observed values, so you have to find 8 expected values. Sometimes you have less than that, but that's how it works. Okay, I have a question asking me, how do we know if we reject the null hypothesis and fail to reject? Okay, this is the critical value, guys, that we got from the table. If, and the rejection region is always to the right of this critical value. If the test statistic that you got is less than that critical value, you fail to reject the null hypothesis. If this was more, let's say this guy's was 9. So then chi-square 9 will be more than 7.8, will be here, it will be in the rejection region. So if the test statistic from step number 2 is bigger than the critical value, you reject HO. If it is less, you fail to reject HO. Now I'm gonna show you how to use the calculator to do this. Actually, you're gonna like that. And that would be the last test. Well, no, we have one more for section 10.4. Okay, guys, you're ready? So we're gonna do some work here, but you don't need to do any expected values at all. You don't need to do any calculation whatsoever to do this on the calculator. In order to do this on the calculator, first of all, you have to state HO and HA. You have to state the variables are independent as your null hypothesis and the variables are dependent as your alternative hypothesis. And that's it. You let the calculator now find chi-square and find the p-value. And let me show you how. I'd like you to bring your calculator, have it handy, and show you how to do that. I think you guys agree with me that there should be a way to enter those values into the calculator, but not into a list, because this is a table, guys. This is not a list of values. This is a table that has rows and columns. And now if you ask me, does the calculator have a way to allow us to enter or key in tables? Yes, there is a way, and I'm gonna show it to you right now. Okay, ready? Let's do it with the calculator. I'm gonna go step by step. You can play this part of the video, guys, later to see how the calculator is used. So I'm gonna start, and I'm assuming that your calculator is ready. And first of all, you have to press the second key. And matrix. Matrix, guys, is where you input a table with rows and columns. So you should see this now. You should go to edit and press enter. So edit and press enter. Now the matrix is asking you, the calculator, how many rows do you have and how many columns? The first number is the number of rows, and I do have 2, but I have more columns. I have 4 columns. So I need to change number 3 to 4 and press enter. And you guys, you can see, does it look like a table here? It looks like a table. So just start entering the values. Enter them as you see them on your piece of paper. So 39, enter. 156, enter. 25, enter. 83, enter. 31, 98, 90, 75. Yes? I'll wait for a second until you comprehend this part, because that's very, very important. All right, guys. So now you have the matrix. Quit. How do you quit it? Just like this, second and quit. And now let's go to the tests. Stat, tests. Okay, scroll up, guys. Your test is at the bottom of the list. Can you guys tell me what test would that be? There is only one left. No, we have a news here. Any guess? What would that be? Let me see what some students said here. C, I agree. The goodness of fit test is D, which is for the goodness of fit. It is C, guys, indeed, chi-square test. And look, it's very easy test. You will see how easy it is. Actually, you don't do anything, guys. It's asking you, did you put the observed values in A? Well, you did. The expected values, you don't have to worry about them. The calculator is gonna generate them for you and put them in B. So all that work we did, guys, we spent about 20 minutes doing all of this. The calculator is gonna do it for us. Okay, and now just hit calculate. Ready? Okay, so I got 3.2904 for the test statistic, and the p-value is 0.3490. You can see the screen, guys. And if using the p-value, so chi-square test using TI-84, write them right here. Input values from the table into matrix A. Then go to tests, chi-square test, and then you will get chi-square equals 3.290. And you guys, if you ask me why this is different from the answer 2.997, remember we rounded. I'm not rounding when they use a calculator, so both answers are acceptable. They're both fine. And p-value is 0.3490. And you guys agree with me, this is bigger than alpha. And if it is bigger than alpha, what do you do? Fail to reject. HO. And the conclusion is very much, it's very much the same. Okay, guys, so that's how, this is how we perform what we call the independence test. I'm gonna do another exercise with you guys and wrap this up, but we'll use technology this time. Yes, if you do the handwork, you're gonna get the same results. Yeah, exactly. So let's do one now without doing the work by hand and see how smooth it is if you don't have to calculate the expected frequencies. So I'm gonna show you how to do that in a second. Okay, so we're gonna do number 15 on page 544, trying to quit smoking. The contingency table shows the results of a random sample of former smokers by the number of times they tried to quit smoking before they became habit-free, and gender. At alpha equals 5%, can you conclude that the number of times a person tried to quit smoking before they were habit-free is related to gender? So we want to study, guys, if it is harder for a man or a woman to quit smoking. Is it harder for a man or a woman to quit smoking? And how many times does it take, you know, just a person to quit? Would it be more times for a man, more times for a woman? We want to study if there is a relationship. Which one is more persistent than the other? This is what the question is about. So we're going to state the null and the alternative hypothesis. But before we do that, guys, I would like you to enter those values into a matrix. And I'm going to do it even before I do anything else. So let's do this together. So I'll have the calculator sideways here. And what do you do first? You go to second and matrix. Watch. This is the matrix. And then you go to edit. And can a student tell me how many rows and how many columns we have here? What is it here, guys? Two by three, I agree. So it's just you already have a 2, then you go to 3 and press enter. And type over the stuff that you have, guys, no problem. You can type over it. So 2 by 3, 271, 257, 149, 146, 139, and then 80. And I think this is all I need from the book. He says alpha is 0.05, so we're just going to state the null and the alternative hypothesis, and that should be it. So I hope that you guys, you're following up with me and doing the same work on the calculator to see how the calculator works. Okay, now we'll just state HO and HA. HO. You, for HO, this is what you write, guys. Number of times. They tried to quit smoking, to quit before they were habit-free and gender are independent. Here you go. HA, same language but dependent. Number of times they tried to quit smoking before they became habit-free and gender are related. So it does matter whether you are a man or a woman and the number of times you need to quit smoking. And he says, test the claim that they were habit-free are related to gender. So you guys agree with me that the claim is right here. Okay. And now, input values into matrix A. We did that already. And I'm ready to run the test. Go to stat. I'll write down the steps. Tests, and then chi-square test. Okay, let's do it. Stat, tests, scroll up, chi-square tests. A, B, you don't need to do anything. And then just hit calculate, or you can do a draw. Okay, chi-square. Wow, it's almost 0. 0.0019 or 0.002. P-value 0.9991. Okay, so just trying to make sure that we didn't. Yeah, so we're good. And you guys agree that this is more than alpha? Fail to reject HO. There is not enough evidence at the 5% level of significance to conclude that number of times they try to quit smoking before they became habit-free and gender are related. So we're saying they're not related. It doesn't matter. It's hard to quit smoking, whether you are a man or a woman, it doesn't matter. Before they became habit-free and gender are related. I'm saying we cannot support that they are related, so probably they're not related. This is the conclusion, guys, for the problem.